In this example, we're going to be writing exponential and linear models given non-yearly rate. So for problem 7, we have a disease epidemic where 1,500 people were infected. We want to write a function model for the number of people, P of t, infected in this region t years after 2000. So let's look at part A. In part A, the number of people infected increases by 800 people every 2 years. Because I'm told the number of people, the exact number of people that are impacted, that is a linear situation. So I need to find my slope. If my linear function changes by 800 people every 2 years, that means it changes by 400 people every year. So I can write my equation here, my function P of t, as my starting number of people, 1,500, plus 400 people times t. T again is years. For part B, the number of people infected increases by 20% every 3 years. So this 20% tells me that I have an exponential situation. It's exponential growth. My B value is going to be 1 plus r, where r is 0.20. So 1 plus 0.20 equals 1.20. So my P of t equals my starting number of people times my base, my B value. Now, this 20% is applied every 3 years. So in 1 year, I would apply t over 3. So I need to change my exponent to a unit that would give me a 1-year increment. So if it's every 3 years the increase is applied, then my exponent needs to be time over 3 to bring my time value down to 1 year. Part C, if the number of people infected decreases 10% every quarter or 4 times per year. So again, because I have a percent value, I know that's an exponential decrease. My R value is 0.10. So B is 1 minus R, which is 0.90. So my P of t is going to be my initial population, 1,500, times my R, 0.90. Now because this 10% is applied 4 times per year, I need to make my exponent 4t to bring that up to an exponent that will have a yearly impact, 4 times t. So notice, if my increase or decrease is applied every certain number of years, I'm going to divide by that number of years. If it's applied more than once per year, I need to multiply by that amount in my exponent. So for part D, we have the population decreasing by 200 people every 6 months. So 200 people, I'm just going to write PPL every 6 months. Well, 6 months is 0.5 years. And if I divide 200 by 0.5, I get 400 people per year. This is a decrease, so my population of people infected starts at 1,500 and decreases, so minus 400t. So similar to what we had in part A, but part A was an increase and part D is a decrease.